Hello students, we are discussing now integration. If we know the function f of x, then we can easily differentiate, then we get the differentiable function dou f by dou x, df by dx or otherwise. So to get back that function f of x, again if I want to get back this function f of x, then the reverse process is required for this differentiable function. This differentiable function, to get back this function f of x, we will do the integration. This reverse process is called as a integration. So in integration there are a lot of applications are there, too many applications in the present scenario. For simple example, if a dam containing a full of water, then we can exert what is the force on that dam, and we can also observe what is the change in force in the water dam to changes various levels of waters. Next, if a function f of x, for example, is equal to x square, if I will differentiate it, it will give 2x. So to get back this function from 2f(x) to x square, we will do the integration of this differentiable function, that is integration of 2x dx. The integral sign is, this is the integral sign. Here integration is actually derived from the sigma sum. This is our sigma sum, means this sigma sum is as it is like this. Now at last this will be derived as a integration. Now this 2x is called as a integrand. This 2x is an integrand. We know that integral 2 is a constant, it will comes out, and x dx. So this is equal to 2 of x square upon 2, again it is x square, plus we will mention some constant c, that is called, that constant is called as a integral constant, integration of constant. Why? Because with this constant we are adding in certain functions, for example x square plus 15. So for differentiating of this function also you will get the 2x, as well as integral x square minus 20. For this also we will get the differentiation 2x. While doing integration, you won't get that minus 20 or plus 20 or minus 15 or plus 15, such values. Those constants, unknown constants, are we will treat it as a integration constants. C. Simple diagrammatically I will show it. For example, x square, after differentiation it will be 2x, and after differentiation integration it is comes as an x square, and here c is an integration constant. There are so many fundamental formulas are there for the integration. For example, integral x power n dx. So x power n plus 1 upon n plus 1 plus integration constant c. Similarly, simple example for this type of problems, integral 2x square plus 5x dx. So to do the integration of this particular function, we will get 2 into integral x square dx plus 5 into integral x dx. So 2 into x square formula here, n value is 2, so 2 plus 1, x power 2 plus 1 upon 2 plus 1, plus 5 into x power 1 plus 1 upon 1 plus 1 plus integration constant we are taking c. This is equal to 2x power 3 upon 3 plus 5x power 2 upon 2 plus c. So after integration of this function we are getting 2x cube upon 3 plus 5x square by 2 plus c. So this is one example, and another example, if we see, if it is plus, then we will take it as a plus integral x power 5 minus 3x power 4 plus 5x cube dx. So this integration, if we apply x power 5 plus 1 upon, similarly we will do the same integration for this also. And another example, another applications of integration is also there to calculate the arc lengths as well as cylindrical spines as well as arc lengths of two surface area as well as volume of an integral. All these things are, so many applications are available. So thank you.